Fail, 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 fail. That life. Okay. This is what we're going to look at. Copy down this example here, and we're going to kind of explain it. Okay. Show that all real zeros of the polynomial p to the fourth minus 3x squared plus 2x minus 5 lie between -3 and 2. Essentially what we get is if we divide out by x minus 2 and x plus 3, we're using synthetic division, we get certain things that happen. And what we're going to get here is we're going to get values in which provide us either all positive entries, if it's a positive number, this is 2. These are all positives. And there's a better example that we're going to show here. If it's a positive and all the positive entries are here, that means we have an upper bound. If they alternate plus to minus, plus to minus to plus, and our entry is negative, that means this is going to mean that it's going to be a lower bound. So you guys have already been doing a lot of these already. I'm going to show you what I mean by that. So that's all you got to do. Doesn't matter if there's zeros. We just want to be, if there's zeros on the equation, that means they're just zeros, right? But if they alternate signs, we're going to look at them. Yes. Right. If they're all positive entry, positives using synthetic division, and the positive entries for your quotient is going to mean that it's an upper bound. If they're alternating and we're using a negative value to find using synthetic, it's going to be a lower bound. And we'll show you what we can do with these. But as long as you understand that concept, this is all we're going to do. This is the only thing that we're going to look at. And this is going to kind of sum up the rest of our understanding of our polynomials and stuff. It doesn't matter that our entries are going to end in whole numbers. We don't care about the remainder. We just want to look at whether they're alternating. Okay. On the test, I can give you something. Is 2 an upper, lower bound, or neither to the equation? If it doesn't alternate, or we have 2 positives, then alternate and a negative, it has to be alternating. If it's a negative, it has to all be positive for upper bound. If they're all negative, it's neither, right? It has to be alternating. So there's 3 different cases we can look at. And I'll show you what this idea becomes. So don't freak out. Don't freak out. What kind of Starbucks did you get me? Caramel macchiato. I like those. So tasty. Get too wired too much. That's why I haven't had coffee all this week. Get too shaky. Trying to convince the wifey to make me ribs today. Right? Try. She made me tri-tip yesterday. And I'm sorry because I ate it all. It was she started cooking at 2:15 at 250 degrees. We didn't eat till 6. Slow cooked it all day long. Delicious. So good. Little side salad. Sorry. I get excited. I'm sorry. I'm hungry today. I get my next food at 10 o'clock. Here we go. So don't worry about that. Let's copy down this one. This one, just jump into examples. It's going to kind of make sense. It says, use synthetic division to determine the values in upper, lower bound, or neither. Okay. You're going to have 2 examples like this on homework. It's going to give you values. Check to see whether they're uppers or lower bounds. Okay. Now the first thing we're going to kind of look at is we're going to look at all possibilities of our numbers. We've got to look at all possible zeros because all the possible zeros are going to kind of help us determine how do we choose these values to find the upper and lower bounds. Our possible zeros for this will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The potential upper and lower bounds where our numbers can exist or where the end behavior might happen will go between -6 and 6. It's the biggest numbers, right? So any number between -6 and 6 can be potential values, right? We're looking at +1, -1, +2, -2, +3, -3, +6, and -6, right? These are the possible numbers we can plug in. But essentially what we're using is we're going to use this upper and lower bound idea to eliminate possible values. These will help us eliminate several values in order to determine what type of values we can take off, what numbers we can eliminate. It's okay? I'll show you right now. What's our first number we're going to use for our synthetic division? -2. So we're going to use our x value as a lower bound. So let's check out -2 here. Let's see if -2 is a lower bound of this. We're going to use synthetic division. 1, -3, -6. So we're just going to use synthetic division on this. Lower bound tells me my signs need to what? Alternate, right? If they alternate, it's considered a lower bound. So because the sign I'm using in here. Dropping this down 1, we get -2. We get -3. We get 6, 7, -14, -17. And then we get, what is this? 14. +34. 20 what? Now, we go from plus to minus, plus, minus, plus. Do these alternate? Since these alternate and we're using a negative value, a negative input, this means that we have a lower bound. We'll put this into context right now of what I mean, what problems it gets eliminated. But we know the lowest value that this function will take on will be -2. Yes? Doesn't look at the remainder. We're just looking at the signs. So don't freak out. You should see one of the other ones that we're going to do is going to give you a huge number. But we don't care about the ending. We just care whether the numbers are positive or negatives.
Basically the one that ends up doing the plus minus or all pluses.
Yep, that's what we're going to look at. The next one we're going to use is what? 1. 1 is a positive number. That means if it's all positives, we're going to have a upper bound. But let's check it. 1, -1, 1, -3, -6. If we do this correctly, 1, 1, 0, 0, 1, 1, -2, -2, -8. This goes positive, 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 negative, negative. Is it alternating? Are they all positives? So this is neither. Neither, neither, neither. Tomato, tomato. Potato, potato. Okay? I don't know one ever uses that as a reference. Okay? If it alternates, this has nothing to do with it. What value is this? Well, it was just a possible value we can use. That's it. That's the only thing we're going to get from this. Now, doing our last case, we're going to use 3. We're using a positive value. That means if all of our answers are positive, that means we have a upper bound. So doing this one should work. 1, 3, 2, 6, 7, 21, 17, yeah, 18, 54, 48, right? Are these all positive, right? Positive, 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 and positive. Our answer is positive. These are all positive. That makes it a upper bound. Now, this is the idea we want to come across. If we were to write out the range of all of our possible answers in the number line, we're going to get this. Our number line would be -6, -3, -2, -1, 1, 2, 3, and 6. These are the potential zeros we have on our number line. Right? These are potential zeros we have on our number line. But because we found out our lower bound, what does our lower bound have to be? Lower 2. So in actuality, we can eliminate -3 and -6 as potential synthetic division problems we can use to find zeros. What's the upper bound? 3, right? So we can automatically eliminate 6 again. So instead of doing all 6 variations or all 8, it eliminates you doing these ones to determine what zeros you have for this function. Because now the upper and lower bounds have to exist between those two. When you get values or you get potential zeros bigger than 3 or 4, and you'll see on the next one that it's going to be nicer to use these ideas of upper and lower bounds so you can eliminate problems without even doing synthetic division. Does that make sense? But we're not going to get into depth. I just want to show you this is what it will be used for. All I'm going to do is I'm going to put this on the test and go, use this polynomial. Is x equal to 2 an upper, lower bound, or neither? Tell me. That's all you're going to do. Very simple, very straightforward. Yes? So I'd give you something like exactly a problem like this. It'd probably be without these two and go, is -2 an upper, lower bound, or neither? You would do the work, found out they're alternating and go, it's a lower bound. That's all you're going to do. You're going to circle it, probably be multiple choice. That's all you're going to do. Okay. Let's look at another type of problem. Let's look at this one. Copy down this example. This example. We're just doing it 3 times. I'm not asking you to do a lot. I'm sorry. Don't be mad. Woo, she said yes. Sorry. Get excited. Party at my house? Negative. That would be selfish. This one's a long one, but I want to show you that regardless, we can still find it. Instead of doing it 10 or 11 times, give me the potential zeros for these. And you'll see it gets kind of crazy. Because look at our 2 numbers. What are our 2 numbers in this case? 2 and 30. So we're going to have a lot of numbers in this case. And these are going to be potentially helping us out determine what values we're going to look at. If I had to write the list of potential zeros, plus or minus 1, 2, 3, 5, 6, 7, 8, 9, 10, 15, and 30. That is a lot. That's not 73. That's plus. That's not even half of them. Because we're still missing some of them because of the 2. Then we got plus or minus a half. Plus or minus 3 over 2. Yeah, because we have P over Q. P over Q. 3 plus or minus 15 over 2. And that's it. These are the potential zeros we can use. This would be a lot for you guys to check. Now, would I ever have you do them? No. No. Could you do it in the future? Possibly, depending on your teacher. Okay. Might just give you one problem and go solve them. Which ones are zeros? Go.
Do we have to do that?
No, this is why I'm going to show you why we're doing lower upper bound. These are going to kind of help us. Now, it's asking us to determine which one's an upper or lower bound or neither. And they're coming from, -1 is coming from our first value here, -5 is coming from my value here, and it's coming from these values. So if we can determine that, we can eliminate a lot of these different types of problems. We can eliminate 10, 15, and 30, okay, in this case. And even 15 over 2, which is 7.5. So let's check to see whether these are uppers or lower bounds. This is potentially going to be a what? An upper or lower bound? Lower, right? For lower bounds, they must do what? Switch, right? They must alternate. So this is the idea that we're going to look at. Doing the lower bound for this one, let's check it. I don't know if it works. Does it? Did someone do it already? There's a huge number though, right? Yeah. Someone fill me in with the numbers as I do these. I know I could do the first couple, but I know they get too big. 2 here, -2, -11, 11, 7, -7, what is this, 66, -66. Did I make a boo-boo?
Okay, it's a -18 and 11, so it's not a -6.
Oh, yes, it is. Just checking you. Just checking you, making sure you're doing it right. 78, -78, -108. This is going to go plus, minus, minus, plus, minus. What is it? Neither. Because we're not alternating. If it was negative, we have a negative entry. That means they need to be alternating. Yeah, they alternate, but it's not a positive, negative, positive, negative, positive, right? They must alternate. They do alternate at some points, but they don't do it constantly. We have to make them alternate constantly. So all has to be positive. If it's negative, it must be all alternating. Yes?
So you have to get the plus or minuses, all the zeros for the answer first.
Yes.
Because
Because I'm showing you why the upper and bounds and this rule works, why this lower bound and upper bound works. The top part is the extra portion to it. No. I'm just showing you where they're coming from. If I ask you what would be the upper and lower bound, you would have to write out all these potential values, and you have to show me, yeah. Right? You would have to do it 6 times and go, I know 6 is an upper bound, I know 4 is a lower bound. Right? We can do it that way. Right? We'll get to that. All I'm going to ask you right now is -5 on upper or lower bound. That's what I do. I want you just to have this idea of what, not just to go through the motion and go like, this is how I want you to do it, apply. I want you to just be able to understand. Yes? I have no idea. I'm not a good speller. Neither, none. I don't care. Huh? Yes. I'll probably put something like this, three questions and go, are the uppers or lower bounds or neither? So tell me A, B, or C. Circle one of them. Probably even multiple choice for this one. Very, something very similar. So, okay. For this one, we're going to do the next one. -5 does a big number, right? Yeah, it's going to be big. Someone help me out with this. I know some of you guys already did it. This is a lower bound, yes? Yeah, cool. I'm going to drop down the first one. This is going to give me 2, -10, -19. What does this give me? Positive 95, 77, -385, negative what?
No, then that's going to make that a positive.
Then positive. Look at you. Lower bound. So we're going to just subtract them. So 15, 40. So this makes it positive, minus, and this makes it a lower bound. Hard or easy? This is why I wanted to teach you because it was on the test. So I'm like, I'm going to do it. I'm gonna do it. I feel like this is extra, but it's okay. Doesn't matter how big this number is. Don't matter. Last one. It's going to be 6. This is going to be big again. Not as big, but it's still going to be big. -2, 9, -18, 71, and 30. First one's going to give me 12. 12 here gives me 3. This one gives me 18, 0. Oh, we could consider it as a positive, right? It's non-negative. It's a non-negative. It's a non-negative.
That one gotta be up. Because that one's gonna be up. That's all it's gonna be.
I don't think just because I'm going to give you that. Don't think I'm just going to give you that. I can give you 2 positives. I can give you like 2 neithers, a lower bound. I can give you, so I might just do that. I might just give you 2 problems instead of spending more time on this. So don't think I can give you that. Don't freak out. 71 times 6 is 42, 6. And this will give me all positives, positive, 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 and positive gives me upper bound. So my numbers will exist between -1 and what? Oh, sorry, -5, sorry. -5 is my lower bound because it's a lower bound. My upper bound is going to be from 6. So the potential numbers, this is the extra portion to this. Our extra numbers that we can absolutely eliminate is going to be 15 over 2 is 7.5, so that's above 7. 30, 15, 10 get all eliminated. So the potential numbers we can actually use eliminates quite a bit. So these are potential numbers that we can get here. Okay.
So the 2 falls up. That one's over 2. Is equal all the way to 6 on that side too. So you just get the rest out.
Our possible numbers in this equation, our possible number line points, or our possible zeros, now will be -5 because -6 won't work because it's lower than that. Then we can do -5, -3. I believe it's going to be -3 halves, -1, -1/2. I'm trying to write them out. 1/2, 3 halves. -2 here. 2. Yes, question.
So how come it's not like 65, 6, and -5, 6? How come it's not like it's the numbers in between those, right?
Yeah, it's the numbers in between those. So all the rest of these numbers exist between -5 and 6. I just want to show you that we can eliminate 10, 15, and 30 because those are over and above these numbers. Does that make sense? It's going to take you way too long. This is like, I would have to have you just do it. If I would have you do something like this, it would have to be, can you graph this equation? You know, this is the culmination of everything. This would be able to, if we wanted to give you some kind of problem like this, I would have to put this as just one part of your test. Because I would have to ask you, okay, what are the upper and lower bounds for this? You would have to test out all these problems. Can you tell me the end behavior? Well, yeah, it's a positive, so that means it's going to probably be going both up points like that. How many times does it change direction? What are the zeros? That kind of thing. And then graph it. So there's a lot more that encompasses everything we've done, but I'll probably just break it into small chunks. Does that make sense? So yeah, this is where the extra part comes in. Like, why do we know what upper bound and lower bound is? Well, we need to know it. Right? This would tell me that my numbers are going to be between -5 and 6 for these equations. Yeah. Yeah. Makes sense? So that's all I want you to take away from me. Okay. Here we go. The last thing we're going to do is something like this. So copy this down. Copy this down. You have one example like this on today's homework. We have about 10 minutes left, so I'm just going to do 2 easier ones. They're going to be kind of nice. One thing that I want you guys to know is we always what's called conjugates in these, so they always come in opposite forms. If we have plus 1 plus I, that means we're going to have 1 minus I. These are called conjugates, complex conjugates, meaning they're always going to, if you have one of them, you have to have the other. Because the idea behind this, the idea of the imaginary numbers, the square root takes both plus and minus. So if it's not there, put it in. And I'm always going to give it to you because I think kids mess up on that. So I'd rather give you something that you can actually do. Find a polynomial with integers coefficients that satisfy the given condition. So even though we're given a degree 2 polynomial, so it's like a squared plus bx, ax plus bx plus c, we want to be able to write it out using these as our zeros. And it can be done. We know these to be factors or zeros, so we're going to be able to write it in factor form and then expand it. I like this problem because it requires you to look back at pretty much test 1, expanding out the polynomials. One of them that I did last period was like super long, but I'm not going to kind of do. You're exactly right, ax squared. Thank you. Ax squared, thank you. Get too ahead of myself. Absolutely correct. What we're going to do first is, because I know these are my x's, x is going to be equal to 1 plus I, and we're going to get 1 minus I. Then when I put these into factors, we can actually expand this out. When we put these in their first factor, there's going to be x minus your term. It's always going to be that way. We always put the opposite values in, and then 1 minus I. And all we're going to do is we're going to, we're going to expand it. There's going to be an expansion. So we got to take them and expand it. This will be x minus 1 minus I. And then we know this will be x minus 1 plus I. So we're going to distribute these ones in here like so. And all we got to do is just FOIL this thing out. There's a lot of errors that can happen from these, but if you do it slowly or do it in different color pencils, doesn't matter if you box them, square them, circle them. I'm going to do that just that to show you guys that it can be done. Our first one here is going to use our x, so we're going to FOIL this out. First, middle, and last will give me x squared. We always, whenever we're plugging in, like let's say if x is equal to 2 and that's a factor, it would always be x minus your value. Right? In this case, we always just do -2, right? But if you plug in 2, this would be x minus 2. So it's always going to be the same. X minus will always be what you're going to use. It will never be x plus. But if you use this idea, you have to use it the whole time. So it's always going to be x minus. Just plug in your value. It will always give you the opposite. Right? We're always just doing the opposite. But because our complex numbers have 2 components, we have to alternate both parts to them if you plug them in, right? So this is now going to become this plus and minus, or this is plus plus, now becomes minus minus, minus minus, right? You can do it that same way. You just got to remember it. Okay, so we're doing both components that are negative. Okay, now, continuing this idea, we're going to get our middle terms. Our x times 1 is negative x, and then our last term is plus xi. That is our first term there. We're going to do our next one with -1. This will be negative x with our first term, plus 1. And our last one will be plus minus I. Then our last term, negative ix or xi. We'll do xi. And then that's our first term. Middle term is going to give me plus I. Last term will be negative I. What's I squared again? Remember that? Remember who you are. So I was watching Lion King yesterday. Good movie. Yeah. What? What? Oh, did he really? When I used to go here, there used to be a guy that used to be, he used to play in the Lion King musical out there in the Pantages. So he used to be a dancer, and he used to do the introduction. He used to do it before every Saturday practice. Love the guy. Super cool guy. Always want to go. I want to go and take a. Whatever. Long story short, let's keep going. In this case, we're going to go ahead and combine like terms. In this case, we have x squared as first one that doesn't change. We have our negative x and our negative x, and give me negative 2x. Negative 2x. Our plus xi minus xi go away. Our minus I and our plus I go away. So when we simplify this out, we're going to get plus 1. And then what happens to this minus I? We're going to drop this minus I squared down. You could have probably already did it. What is I squared again? Negative. So minus negative 1, which is becoming what? Plus 1. So we get this minus 2x plus 1 plus 1 is going to be x squared minus 2x plus 2. So we're just expanding it. Again, the key part of this one is here. I'm sorry? That's our final answer. That is the polynomial that would be done. If you were to use a quadratic equation, which you would have to, you would get your solution to be plus or minus 1 plus or minus I, which is what our solution would have been up there. It was just an explanation. It was just an explanation I'm plugging in. Don't worry about it. Yeah, that's nothing. My bad. I should erase that. Homework? You only have 3 of them. If I can get you them. Yeah, you only have 3 of them. Don't worry about those ones. Copy those ones down or take a pictures of it. You also need, so this would be and negative I. You also need that in there. This is 1, 2, and 3. Say what? CSN? CSUN? Son of Nevada.
Like my conflict was going to be private school because application fee. But my sister said that she didn't have to.
Call him. Find out. It might be because he's a Nevada resident. I don't know. It might be different. I don't know. Maybe she just got a waiver, or I don't know. Maybe they applied it for her. I don't know. I could do a PowerPoint presentation on it as well. So not a worries. Yeah, no. I got you.